In quality, you don't always get to choose what parts show up next. A print arrives, a badge comes in, a customer sends a component with features your current setup wasn't designed for, and you have to figure out right now how to verify it. Maybe you reach for your optical system and realize the feature lives in 3 dimensions, and your system only understands 2. Maybe you move to the tactile CMM, but the part won't tolerate being touched or the features are too small. So you adapt. You work around it, you spend time you don't have, and you accept the result you're not fully confident in. Because production is waiting and you don't have a better option. Most quality teams are working with a toolbox that was built over time, piece by piece, system by system, as needs arose. The gap between what your toolbox was built for and what's actually arriving, that gap has costs. Not the kind that always show up numerically on the report. They show up as setup time that bleeds into the afternoon. As an operator who made the best call they could with the tools available and spent the rest of the day hoping it was right while also feeling stressed that I was missing something. Less time lost to method decisions, fewer results that require qualification, and a team that can release parts with confidence instead of reservation. So what does a measuring system that actually closes it look like? The ZEISS O-INSPECT is an advanced vision measuring machine. Its core strength is 3D optical measurement, extended by tactile and white light sensor capabilities. All 3 operate within a single calibration. Where part variety is high, the methods required are mixed, and accuracy cannot be negotiated. One machine, one setup, one coordinate system. When you need to see a feature, you see it. When you need to touch it, you touch it. But calling it a vision measuring machine means the optics have to actually earn that. Most people who've worked with vision systems know the frustration. You measure the same edge twice and get 2 different numbers. You change the zoom level and the result shifts. You move from the center of the field to the corner and something changes that shouldn't. Those problems almost always trace back to 2 things: optics and lighting. The 2 aspects of a vision system that are hardest to get right and easiest to cut corners on. ZEISS has been building the world's most advanced optical systems for over 175 years. The optics in the O-INSPECT come from that same engineering discipline. The lens eliminates perspective error across the entire field. The lighting system can be controlled in segments, wavelengths, and angles. So when a surface is difficult, you have genuine tools to make it readable. Let's show that on a real part. What you're seeing there is the measurement staying consistent as conditions change. Different zoom, different position in the frame, different surface finish. That stability is what a telecentric lens and controllable lighting actually deliver on a production part. There are features a camera might not be able to measure. Internal geometry, surfaces the light can reach, features recessed or oriented in a way that makes optical access unavailable. For those, physical contact is the only method that will work. The tactile probe on the O-INSPECT makes contact with forces so low they're almost imperceptible, which means thin-walled plastics, medical components, and small precision parts can be probed without the probe itself influencing the result. It also runs without compressed air, which simplifies the installation and removes a common infrastructure dependency. Beyond force, there is the question of data. Discrete touch points tell you approximately what a feature is. Continuous scanning tells you what it precisely is. Tracing the surface rather than sampling it. Capturing the shape rather than estimating it. And because scanning works significantly faster than single-point workflows, that reliability doesn't come at the cost of throughput. For parts that neither the optical system nor the tactile probe can address, highly reflective surfaces, transparent materials, components too fragile to touch in a meaningful way, there is a third sensor available. It uses light to measure depth without contact. The measurement lives in the same coordinate system as everything else the machine has already captured. No reconfiguration, no separate workflow. What you're seeing here is the same environment used across the entire ZEISS CMM family. One part plan, one language, one report. For teams already in Calypso on a tactile machine, there's almost no transition cost. The environment is the same. The logic is the same. The capability expands. For teams coming from standalone optical systems, ZEISS Academy provides structured training on both Calypso and the O-INSPECT specifically. Most vision systems are calibrated in a single plane. For a machine that measures in 2 dimensions at a fixed focal distance, that might be adequate. The O-INSPECT measures in 3 dimensions, so it's calibrated in 3 dimensions across the entire working volume. Temperature is the other variable worth addressing directly, because it undermines measurement confidence invisibly. The O-INSPECT is equipped with temperature sensors and reference scales that are engineered to stay dimensionally stable as temperature fluctuates. Combined with automatic workpiece compensation, it removes the most common source of silent measurement error before it becomes a quality escape. The O-INSPECT, a fully volumetrically calibrated machine, gives you documentation that holds. When a multi-sensor measuring system runs on 2 different software environments, the integration cost doesn't show up on the spec sheet. It shows up on a Tuesday afternoon when a programmer has to maintain 2 separate part plans for the same component, or when a supervisor is trying to explain to a customer why the optical results and the tactile results live in 2 different reports. It even shows up in reporting. Someone manually combining outputs that should have been one document from the start. The O-INSPECT runs entirely within ZEISS Calypso. Optical and tactile features live in the same part plan, executed in the same run. The report is one document. If what we've covered describes your facility, the most useful next step is simple. Bring your own parts to a ZEISS Quality Excellence Center and see the process and results on your components. The link is in the description. The O-INSPECT comes in 3 measuring volumes. The right one is the one that matches the part size you want to run. The smallest configuration is for facilities that measure small, high-precision components. The mid-size configuration is the most commonly specified. It handles the general manufacturing workload. The largest configuration is for bigger workpieces and higher volume workflows. All 3 share the same optical architecture, the same tactile probe system, the same software environment, and the same calibration standard. The choice between them is mainly a size decision. The capability is the same. The specifications of a measuring machine matter. But so does what it's like to use one on a Tuesday afternoon when the schedule is behind and 3 different part numbers are waiting. The O-INSPECT's pallet system is designed for that reality. While the machine is measuring one job, the operator is setting up the next one outside the measurement volume. When the current run finishes, the pallet drops in and the next one begins. The machine doesn't wait for people. People don't wait for the machine. Temperature compensation happens in the background, automatically, when the pallet is loaded. Nobody has to remember to enter a value. Nobody has to wonder whether a result was influenced by a temperature swing they didn't notice. It's handled. The O-INSPECT is an advanced vision measuring machine. And like every special instrument, it's the right choice for specific situations, not for everyone. For a quality manager, fewer workarounds, faster changeovers, and measurement reports you can put in front of a customer or an auditor without qualifying what method you used and why. For the programmers and technicians operating it, one environment for both sensor modes, scanning capability without additional licensing, and a probe system precise enough to handle the parts your previous tactile setup had to turn away. If your facility is running varied part types across mixed materials, and your team is regularly working around the limits of what their tools were designed for, the O-INSPECT is a direct answer to that specific problem. We started with a simple observation. In quality, you don't always get to choose what parts show up next. The O-INSPECT doesn't change that. The parts will still arrive. The variety will continue, the pressure to verify more, faster, with greater confidence, that's not a trend that reverses. What changes is the position you are in when it happens. One measurement environment.